Hello, my name is Anthony.
And I'm Joel.
We are from Group 11 and this is our video presentation for EGB340.
We've been tasked with finding a real-world authentic problem and then conceiving, scoping and prototyping a solution for that problem.
The task that we've decided to focus on is retrofittable security options for motorcycles. These being ones that you can fit to a motorcycle after it's left the factory, something that you might be able to buy from a shop. Primarily, we're also trying to focus on electrical design solutions.
This is because research has found that over 8,000 motorbikes are stolen in Australia annually, and of these, only 45% are returned.
So a couple of our key features of our design here, it's currently being powered off of a 9-volt 550 milliamp hour battery, and what we're seeing is about 125 hours standby time for this one. We're looking to try and increase this later in design by using a bigger battery. From there we go through a 5-volt voltage regulator, which sets the voltage for the 3-axis accelerometer as well as the Atmel chip that we're using here as well. Our design has 3 main stages to it. The first is the input stage, which is part of the 3-axis accelerometer and the small push switch over here. This is the 2 methods which we've determined to try and see if the bike has been stolen or not. The push switch will be located under the seat and activated by seat pressure. The accelerometer is so that if the bike is moved without anyone touching the seat, the input is still measured as well. From here we actually go into the chip. We're using an Atmel Atmega 8535 microcontroller, and that's running all the software which we've designed for this application. From there it's going to output a frequency which goes to our small speaker up the back here. We're using an 8 ohm speaker for this one. The standard frequency that we're using for this is a 3.3 kilohertz signal, but it sweeps up to a 3.6 kilohertz frequency over a short period of time as well.
A key switch to turn the device on and off has been omitted for demonstration purposes. Once activated, the system will flash twice on the user display, showing that the alarm is active. For demonstration purposes, this LED also shows when the accelerometer triggers the circuit. The other LED shows when the buzzer is active. For this video, a resistor has been added to reduce the volume of the alarm. Once the user has activated the circuit and gone to do their business, if a thief comes along and sits on the bike to ride it away, the alarm activates through the pressure sensors in the seat. If the user doesn't sit on the seat but still attempts to move the bike, the accelerometer will activate the alarm. Thank you for watching. I hope you enjoyed our demonstration.